So, you want to know about F1 Downforce and Upforce? You're in the right spot.
Don't let me down, I'm burning out, at time.
Welcome back, I'm AVP. Let me walk you through F1 Downforce. Alright, so you ever been on a flight and seen an airplane take off before? Well, F1 cars use the exact same mechanism, but in reverse. So instead of actually taking off, we want to stay on the ground. It's called downforce. So, downforce is a term used in Formula One to describe the aerodynamic loads imposed onto the car during a race. So the other thing about downforce is that downforce is a function of velocity, the airflow coming in, the planform area, as well as the the lift coefficient, or I hate using coefficients here to describe lift or downforce or anything like that, but yes, downforce has a lift coefficient, but I'm almost tempted to call it the downforce coefficient, not lift coefficient, or the negative lift coefficient at least, because we're generating lift the opposite way. Downforce is actually calculated by computers these days, but it's essentially just an integral of the pressure along a specified planform area. So you could say, well, it's a planform area off the either underbody of the car, and so forth. But let me first break down the different parts of the Formula One car that generate downforce. So one would be your typical underbody of the car, which is not very visible, but the most obvious and most important is the front wing. The front wing, the rear wing, the chassis or the bodywork, the underbody of the car. Now, there are other honorable mentions I'll mention at the end that generate downforce as well, but for now, these are the main contributing components. The front wing actually uses the airfoils to generate downforce, but it also uses the ground effect mechanism to take advantage of take advantage of the ground to create a little bit of more downforce. The rear wing, I hate to swoop in right now with the rear wing, but the rear wing generates the downforce not the same way as the front wing, because it generates the downforce by actually minimizing drag or increasing the downforce. The rear wing is very fundamental and integral in overtaking. Now, the rear wing is essentially the FIA's baby in terms of the aerodynamic loads imposed onto it and so forth. But what you really want to know and understand about the front and the rear wing of the Formula One car is that they generate the same percentage of downforce. This is because if you generate way more downforce at the rear of the wing of the Formula One car, you're going to end up with oversteer problems. On the other hand, if you end up generating more downforce in the front wing of the car, you end up creating understeer. Understeer and oversteer are essentially handling issues that F1 drivers experience every now and then. This happens sometimes, you'd find out sometimes the F1 car, the guy lost his rear wing or something like that, and his front wing is generating way more downforce and experiencing understeer, or he loses his front wing, and now his rear wing is actually generating too much downforce. He experiences oversteer. So these are the typical kind of complaints that you hear in F1 radios when they're communicating with their, station briefers or something like that. But yeah, essentially, you want to balance that force at the front and at the back. The front wing, as the air sweeps in, it's not just responsible for creating downforce. It's also responsible for directing the air down onto the underside of the car, up onto the sideways of the car, into the side pod for cooling the engine and other particular components. Now, with this particular one, I have to mention there's something called a Venturi Effect, which is a bit of a technical term here. I'm not going to cover it up entirely, but I will say that it's a way that Formula One car underbody sides, right? So underbodies that are smooth. The underbody, by the way, has to be smooth to effectively generate downforce. It has to be smooth. You have to have that laminar flow in there. That's why. Laminar flow just means that you have flow at lower Reynolds numbers, you have a smoothly behaving flow. That's essentially what it means. Turbulent flow, on the other hand, is a bit more aggressive, a little bit more chaotic. You don't really want that on the other side of your car. So you really want to maintain that smooth surface finish right there. The Venturi Effect then creates this sort of suction underneath the car to keep the car down. In other words, it pulls the car down onto the floor, and it takes advantage of the ground effect mechanism to do this, to achieve this. That's how we create downforce in the underbody of the car. So rail rings are actually a very interesting aerodynamic feature that Formula One cars have, for me personally. This is because they are adjustable, and they act much like ailerons on aircraft. If you want to bank left or bank right, you drop down your left aileron to bank left, you drop down your right aileron to bank left, and so forth. Same thing for Formula One cars. But instead of banking left or right, you actually want to go faster. But now, if you want to go faster, you just simply drop it down and shoo, off you go. No, actually increase angle of attack up, and shoo, off you go. It's called the drag reduction system, or the DRS, right? At least that's what the stewards call it, DRS, drag reduction system. So yeah, that's how the drag reduction system works. Upforce simply means lift, because lift is simply negative downforce, because downforce is negative lift, because downforce is also negative upforce. You're still following, right? Good. We've had this in the past. We've seen these races. Tragic accidents where Formula One cars just take off the track and just fly off to space. Upforce is simply lift. It's actually lift. It's just, again, upforce. It's a very, I kind of crafted the term up just like 10 minutes ago or whatever. All right. Anyways, upforce is not desirable on an F1 car. In some instances, it is desirable on the chassis, though. In fact, sometimes F1 engineers put on, lift generating surfaces on the F1 chassis. This is to essentially induce downwash or upwash, to the trailing edge parts of the vehicle to create more downforce. So, yeah, actually, lift is kind of desirable, sometimes upforce. However, there are some times when lift is just undesirable. For example, if one car is directly behind the other, Formula One car directly behind the other, and they touch or make contact on their wheels, this may result in pretty unpredictable air disturbances, which could send the car flying off the track, could turn the car upside down. There's just different main ways things could go bad with accidents in Formula One. And so, because everything is designed so aggressively to keep the car down, if everything just goes the opposite way as intended, things could go aggressively up into the air and then come crashing down. We don't want any of that. So upforce is essentially just, when cars, accidentally bump into each other and they accidentally generate lift onto the parts that are actually designed for downforce specifically, and that could send the car flying off the track, could send the car onto the barricades off the circuit. So this is really bad news for F1 drivers. All right, so let's just take a pause right here for now in terms of just talking about downforce, upforce, and Venturi effects and so forth. I'm going to show you guys, I think I'm going to, just expand a little bit on this topic of downforce. Maybe I think I'm just going to, add in, a second segment of this very same topic, because I feel it's really, really important in understanding how some of these races come about. I always take into consideration that I could have made a mistake and left something out. I could have made a mistake in saying something, or, saying some words wrongly. Please do feel free. Leave a comment down below. Like the video. Give it a thumbs up if you liked it. Heck yeah, give it a thumbs up. And join the team. All right. I'll see you on the next one.